Hello, ladies and gentlemen, and welcome back. Welcome back. We're still looking at our 2017 Canadian Intermediate paper, but we're going to start Part B. We finished our sixth question, A6. Now we're starting the last three questions, so these are Part B. You have to show your full work, be very organized, very neat and clear in what you're saying when you try these three questions. And if you haven't tried them already, I would strongly encourage you to do so. We're about to go through question one. So feel free to pause the video and try it out. Okay. What have we got for B1? The first three figures in a pattern are shown below. So three of them, then we've got five of them, and seven of them. So it's basically a 2 by something with the upper corner missing. Figure 1 is formed by three identical squares of side length 1 arranged in 2 rows. The perimeter of this figure is 8. Let's see if that's true. 1, 2, 3, 4, 5, 6, 7, 8. Oh, wow, it looks like they know what they're doing on these math contests. Given a figure in the pattern, the next figure is obtained by adding a square of side length 1 centimeter on the right end of each of the 2 rows. So add a square, add a square. In figure 4, you add 2 squares, add a square, add a square. You've got figure 5, 6, and so on. Okay, a fairly plain pattern. We've got 4 parts here. How many squares of side length 1 are used to form figure 8? Okay, figure 8. Now, we could probably actually take the time to write out figure 8 if we wanted to, but let's see if we can avoid that. Let's see what we can do in terms of just sort of pattern recognizing, because, well, maybe the next question will ask us for how many squares in figure 88, and I definitely don't want to write all those out. So we get 3 squares for figure 1. And you add 2 more on to the next one to get figure 2. So now you got 5 squares. And you're going to add 2 more on for figure 3, and that would be 7 squares. And so you might notice, okay, we just keep adding 2 squares each time. So you could say, all right, I just need to keep adding 2 the appropriate number of times. Or what we could do is we could try and find a formula. 3 is 2 times 1. Okay? So my figure number times 2, 3 is not 2 times 1. 3 is 2 times 1 plus 1. Okay? And 2 times 2 plus 1 is 5. And my figure 3 here, 2 times 3 plus 1 is 7. Okay? Now, if you don't see immediately where I'm coming with these numbers, that's okay. We notice that we go up by 2 each time. Okay? If we call this first one A, this is A plus 2. This is A plus 2 plus 2. How many 2's are we going to need for figure 4? Well, you'll need to add on 3 2's to go from the original 2, 2, 2. Why 3 2's? And why were there 2 2's for figure 3? Well, it'll be A, which happens to be 3, plus 1 less than my figure number. We'll call the figure number n. So you just notice it's 1 less than the figure number. So 3 plus 2 times n minus 1. And we can simplify that to 2n. 3 minus 2 is 1. So 3n plus 1. So you can either spy the pattern right away, or you can work it out. Either way is fine. Okay? But we want to show our work and explain this nice little pattern, so we can say, okay, figure n is 2n plus 1 squares. And now if they ask us for figure 8 or figure 88 or 8008, we're all set. Okay, so figure 8 has 2 times 8 plus 1, 17 squares. Okay, which you could have found if you drew them out. And that's perfectly acceptable, but it's not as elegant, I would say. So B, determine the perimeter of figure 12. Well, I don't want to write figure 12 out any more than I wanted to write figure 8 out, so let's see if we can find a pattern. They already told me that it's 8 for figure 1. Okay? So let's see what we can do. There's our first few shapes. Perimeter is 8 for figure 1. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because those were the units, right? They're all side length 1. So 10 for 2. How about for figure 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, it looks like we're going up by 2 again. Okay. Now stop for a moment and see if you can work out in your head a nice suitable pattern for this. Okay, I'll give you a hint. It should have a 2n in it because we're going up by 2 each time. Okay. So 2n plus 6. How do I know it's plus 6? I need it to match up with 1 and 8. And if I plug in 2 times 1, that already gives me 2. What's left over to make 8? 6. And we can check. 2 times 3 is 6, plus another 6 is 12. Okay? Or you can do the same sort of difference arithmetic sequence work I showed you over here. Okay? But we can see that figure n has perimeter 2n plus 6. Okay? Now, is there a reason we're going up by 2 each time? Absolutely there is. So if we look at this figure here, inside you can see our old perimeter for the previous one that we did. So there's our 8. Okay? So how do we get the new perimeter? Well, we lose these 2, because they're now on the inside, but we gain these 2 on the outside, and plus 2 more on top and bottom when we extend and add new squares out this way. So we lose 2 but add on 4, and that's a difference of 2. Okay? So that's how you can see it's always going to work the same. It's always going up by 2s. So now, figure 12 has perimeter 2 times 12 plus 6, that's 24 plus 6, that's 30. Okay? Figure 8 had perimeter 17, well, or not perimeter 17, had 17 squares. Figure 12 has perimeter of 30. Okay, we're halfway done question 1, although usually they increase in difficulty as you go. C. Determine the positive integer c for which the perimeter of figure C is 38. Now, if in the first question we had just sort of drawn it out to get figure 8, we would have answered that one, but we would have been absolutely at a loss. For this sort of question, this question asks that we work backwards. Okay? So thanks to our previous work, as long as we've shown it, we can just now say, all right, we must have 38, and what do we want? 38 is the parameter, right? 38 is 2 times, oh, sorry, if we had just written out figure 12 in the last question and didn't get a formula, we would have nothing, we wouldn't be able to handle this one. Okay? That's why it's important to look for patterns, create general formulas, rather than just say, oh, well, I can draw. Okay, subtract 6 from both sides, divide by 2, C is 16. We don't really need any further comment. You can give a little therefore statement if you want. So figure 16 has perimeter 38. But as long as your work is clear and your formula was justified by earlier work, you're good to go. Okay, so it's figure 16. Now D, the last bit. Determine the positive integer D for which the ratio of the perimeter of figure 29 to the perimeter of figure D is equal to 4/11. Okay, ratio. So the first thing listed becomes the numerator. The last thing listed becomes the denominator. Okay, so we can again say by our work in B, figure 29 has perimeter 2 times 29 plus 6. So that's 58 plus 6. That would be 64. And we've got a formula for figure D as perimeter 2D plus 6. So we know 64 over 2D plus 6. They're telling us the ratio they want, 4 over 11. So if we divide both sides by 4, we'll get 16 over 2D plus 6 is 1 over 11. If we multiply both sides by 11, we'll get 176 over 2D plus 1, or 2D plus 6 is 1. If we multiply both sides by 2D plus 6, we'll see that 176 is 2D plus 6. Subtract 6 from both sides. 170 is 2D. Divide by 2 on both sides, and you'll get 85 is D. So figure D gives such a ratio, is something you could say. Okay. Very nice and neat. Remember, if you're writing these things up, it's a good idea to put boxes around numerical answers. It makes it easier for the markers to mark, which means they get, don't get fed up while reading your paper. And it also makes it look a lot neater and clearer and more organized. That here are my answers. This is where it is. It's nice, neat. It's good communication. It's something to practice, not only to make it easy to get the marks on your paper, make it easy for your paper to be marked, but it's also useful in real life to have good communication skills and say, here are the important things. Focus on this. Okay. That does it for B1. We've got 2 more questions to go on our paper. We're going to take a look at B2 on the intermediate paper next time.